Example 9.3, Revolution and rotation of the Earth. The Earth orbits around the Sun and also rotates on its pole-to-pole axis. What are the angular velocities, frequencies, and the linear speeds of this motion? So in this question, they have discussed the revolution of the Earth around the Sun and its rotation about its axis. And we need to find the angular velocity omega, frequency f, and the linear speed v for this motion. We need to first find what is the time period of revolution and rotation. Because using time, I will find what is frequency and then omega. So let's start with the time the Earth take to rotate about its axis. So I will write that as t Earth. We know the Earth take around 24 hours to complete one rotation. So t Earth will be 24 hour. This time in hour I will convert in seconds. We know every hour has 60 minutes and every minute has 60 seconds. So when you solve this, you get time in seconds as 8.64 times 10 to the power 4 seconds. So this is the time the Earth takes to complete one rotation around its axis. Then we do the same thing and find the time the Earth takes to complete one revolution around the Sun. We know that the Earth takes 1 year to complete one revolution. So time it takes to move around the Sun is 1 year. Every year has 365 days. And how do we convert these days to seconds? We know every single day has 24 hours and every hour has 60 minutes. Every minute has 60 seconds. So when you convert this time to seconds, you get the time period of revolution as 3.15 times 10 to the power 7 seconds. Once I have the time values, now I can calculate the frequency. The frequency of rotation of the Earth, I will write F Earth, will be equal to 1 over the time it takes for the Earth to complete one rotation. That will be equal to 1 over 8.64 times 10 to the power 4. And that gives me the frequency as 1.16 times 10 to the power negative 5 hertz. So this is the frequency of rotation. Once I have the frequency of rotation, I can find the angular velocity. Angular velocity of rotation of the Earth is nothing but 2 pi the frequency. This is the relationship between angular speed and frequency. Angular speed omega is equal to 2 pi f. And I'm going to use this to find my omega. So let's substitute 2 pi times 1.16 times 10 to the power negative 5. And when you solve, you get omega to be equal to 7.27 times 10 to the power negative 5 radian per second. So this is the angular velocity for rotation of the Earth. Now we follow the same step to find the frequency of revolution. Frequency of revolution around the Sun will be given as 1 over the time it takes to complete one revolution. So that will be equal to 1 over 3.15 times 10 to the power 7 seconds. And that gives me the frequency of revolution as 3.17 times 10 to the power negative 8 hertz. Once I find the frequency, now I can find the angular velocity omega. So angular velocity of revolution around the Sun is equal to 2 pi times the frequency. So multiply 2 pi with the frequency we just found, 3.17 times 10 to the power negative 8. And once you multiply them, you get the angular velocity to be equal to 1.99 times 10 to the power negative 7 radian per second. So this gives me the value of frequency and angular velocities. Let's calculate the linear speed. Now the linear speed v is related to angular velocity as r times omega, where r is the radius of the circular path. So the linear speed v with which the Earth revolves around the Sun can be given as the product of orbital radius r times the angular speed omega. The orbital radius is the distance between the Sun and the Earth. And this distance between the Sun and the Earth is 1.49 times 10 to the power 11 meter. Now this is a constant which they should give you while solving problem. So I'm going to use this while calculating the linear speed. Let's substitute. V will be equal to R is 1.49 times 10 to the power 11. Omega we already calculated in the previous part. So omega for Sun is 1.99 times 10 to the power negative 7. And when you solve this, you get the linear speed of the Earth orbiting the Sun to be equal to 2.97 times 10 to the power 4 meter per second. Then we need to find the linear speed v with which the point on the Earth's surface will rotate. And that will be given by the same expression, which will be r times the angular speed of Earth's rotation. Now this distance r is the distance of the point from the axis of rotation of the Earth. So this red line here is the axis of rotation. And we know since the Earth is a curved surface, the distance of any point from the axis of rotation will change as you move along the curve. Points at different latitudes are at different distances from the axis of rotation. So if I have a point at this position 1 and I have a point at position 2, their distances from the axis of rotation will change, will not be the same. So I can find this distance from the axis of rotation small r in relationship to the radius of the Earth. And we can write small r to be equal to radius of the Earth times cosine of the angle theta. Theta here is expressed with a different font to differentiate it with theta, which is the angular displacement. So I can calculate the distance of the point from the axis of rotation to be equal to radius of the Earth times cosine of the angle theta. Why cosine theta? Because this is my angle theta here. The radius vector is making with the horizontal. And we can use the adjacent angle theorem to state that this angle here is also theta. And since small r is adjacent to angle theta, any side or any component which is adjacent to theta is related to cosine theta. Because when I'm finding cosine of any angle, cosine is related to adjacent side over the hypotenuse. So any adjacent side is always related to cosine of the angle theta. So I will substitute for r here to calculate the linear speed of any point on the surface of the Earth. That will be equal to radius of the Earth times cosine of the angle theta into omega of the Earth. Now radius of the Earth again is a constant, and that constant is equal to 6380 kilometer, which they should give you while solving the problem. When we substitute the value for radius of the Earth and omega Earth, we get r equals 6380 kilometer. Kilometer you can convert to meter by multiplying with 10 to the power 3. The power of kilo is 10 to the power 3. Cosine of the angle theta times omega Earth, which is 7.27 times 10 to the power negative 5. And when you solve this, you get the linear speed of a point on the surface of the Earth while rotating is equal to 464 meter per second times cosine of the angle theta. So you see this linear speed will change when you change the angle theta. The angle theta is equal to 0 degree at equator, and this theta will be 90 at poles. So when you are at a different point on the Earth's surface, the angle theta will change, and the linear speed with which the point moves will also change. Question 9.61. A boy is on a Ferris wheel which takes him in a vertical circle of radius 9 meter once every 12 seconds. What is the angular speed of the Ferris wheel? So here in the question, I have been given the radius of the circle r, which is 9 meter, and I have the period of revolution t, which is 12 seconds. I need to find the angular speed omega. Now we know that omega is given as 2 pi times the frequency. And the frequency is related to the time period as inverse of t. Frequency f is 1 over the time period. So I will substitute that here and get omega to be equal to 2 pi over t. And since I have the value of period t, I can solve for omega as omega equals 2 pi over 12. That gives me the angular speed to be equal to 0.5236 radian per second.